minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition and liftoff of Ares-1X, testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. We started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail-off is observed. Burnout. Our APUs have shut down. CRDs have shut down. BDM fire. And SEP. We show a SEP and a tumble motor ignition. And we can also confirm on video. We see both parts of the vehicle tumbling, the first stage as well as the upper stage. Successful separation. Good clean signal all the way. T plus 150 seconds. We'll have a burnout orbit parameter in just a second. These numbers were calculated right at burnout. The height of apogee, 21.92.
The pressure oscillations from the Ares-1X booster were well within historical levels seen on shuttle flights. As the booster burns out, you see a flash during the firing of the booster deceleration motor. Then you see the firing of the booster tumble motor. The booster begins to rotate and separate from the upper stage. You notice also that the upper stage begins to rotate. This was expected as the upper stage did not have a control system. In fact, the separation event for Ares-1X was more challenging than for the Ares-1 design conditions. Because we only had 4 segments of propellant, we burned out at a lower altitude and higher dynamic pressures, 90 pounds per square foot for Ares-1X, as compared to only 10 pounds per square foot for the Ares-1 design. So this resulted in a stress case separation and was very successful. One thing to watch during the descent of the booster is the trailing smoke from the nozzle. This helps us to see the flight path of the descent, which initially is horizontal to the Earth, and later, as the vehicle slows, will become more vertical. Early on in our engineering assessment for Ares-1X, we were concerned we might have a nose-first re-entry of the booster because of the forward-end weight of the fifth segment simulator. After several refinements to our weight and balance of the booster, we got our predictions down to only a 3% probability of a nose-first re-entry, which proved to be valid on our 1X flight test, as the vehicle stabilized nozzle down for most of the descent. Several oscillations can be seen in the booster orientation, and as speed decreases, the flight path becomes nearly vertical, as seen by the trailing smoke plume. It is interesting to note that during the vertical descent, there was a slow oscillation, and the booster is actually at about a 110-degree angle of attack to the flight path as the drogue chute deploys. This results in several dramatic oscillations under the drogue, but it performs beautifully, and the booster stabilizes nicely after about 4 oscillations. Watch closely at the top of the booster. The forward skirt extension is jettisoned and pulled away by the drogue. This entrains the risers of the 3 main parachutes for their initial inflation to the reefed or partially inflated position. All 3 chutes make it to the first inflation position, but the chute on the left quickly deflates and fails, trailing a streamer which appears to strike the chute in the middle, perhaps damaging it as well. So just prior to water entry, we essentially have 1.5 chutes suspending the booster. Also at this point, you can see the nozzle extension pyrotechnically severed at the bottom of the booster just before water entry. The booster hits at a higher velocity than planned, which causes a hard slapdown and buckling of the aft segment motor case. This has also been experienced in the shuttle program. A total of 11 chute deployment failures have occurred in the life of the shuttle program, most recently on STS-128, so we have abundant data to resolve this for future missions. Ares-1X was also a parachute stress test, as the booster was nearly 40,000 pounds heavier than an Ares 5-segment booster due to the hardware in the 5th segment simulator. The parachutes were a world record-setting 150-foot diameter and were tested at a total payload weight for the first time during Ares-1X. Now that the booster is down in the water, watch for the drogue and forward skirt extension to enter into the image just to the left of the booster. All of these sequences worked exactly as designed. Today, the booster is on dock at Cape Canaveral and is undergoing teardown inspections. In the next few days, we'll be able to recover the data recorders and begin the detailed data analysis of the entire flight.